You are standing in the middle of nowhere. No road, no signpost, no bar of signal on a phone that doesn't even exist yet. The sun is dropping fast behind a tree line that looks exactly like every other tree line you passed today. You went out hunting hours ago, farther than you meant to, chasing a trail that kept curving deeper into land you don't fully know. Now you have to get back. Somewhere behind you. Your family is waiting by a fire, in a shelter that has no address, no pin on a map, no name anyone else would ever recognize. It only exists in one place, inside your own head. So how do you find it? No compass, no GPS, not even a scrap of paper with a few lines scratched onto it. And yet humans didn't just make it home from an afternoon hunt. They crossed entire oceans they could not see the other side of, and still landed somewhere on purpose. Before we go further, if you're the kind of person who wonders what your ancestors actually knew that you don't, hit subscribe, because that's exactly what this channel digs into. And if you've ever been genuinely lost with a dead phone in your hand, tell me in the comments, because you're about to see how differently your ancestors would have handled it. Your first instinct is probably the obvious one. They just followed the sun and the stars. That's true. It's also nowhere near enough. Out on open ice, across flat grassland, in the middle of open ocean, the sky alone will not save you. By the end of this video, you'll understand something GPS has been quietly making you forget. Your brain was built to do this, somewhere behind your eyes. Right now, your brain is quietly doing something remarkable. It's building a map. Not a paper one, not a digital one. A living, three-dimensional map made of memory, distance, and direction, stitched together every time you move through space. Scientists have a name for this. They call it a cognitive map. And for a long time it sounded like a nice metaphor. Nothing more. Then researchers started scanning brains and found something startling. This map isn't a figure of speech. It has an actual location. Deep inside your brain sits a structure called the hippocampus, along with a neighboring region called the entorhinal cortex. And together they act almost like your own internal GPS chip. A landmark review published in Nature Neuroscience laid this out clearly. These structures don't just store memories the way people used to assume. They encode space itself, tracking where landmarks sit in relation to each other and to you. Here's where it gets even more interesting. Your brain doesn't only remember what things look like. It tracks how far you've walked and in which direction, even with your eyes closed, even without looking back once. Scientists call this path integration. Think of it as an internal step counter running in the background of your mind, constantly updating a rough sense of how far from home you actually are. And this is not the same skill as simply learning a route. Following a familiar path from your house to a coffee shop is one kind of memory. Actually understanding the space around you well enough to cut a new path through unfamiliar territory is a completely different mental process. One is memorization, the other is comprehension. It helps to picture it next to something you already know. Your phone finds its position by talking to satellites orbiting overhead, triangulating a signal from space. Your brain has no satellites. Instead, it builds the same kind of result from the inside out, stacking landmark after landmark, step after step, until a working map forms entirely out of lived experience. Call it a biological GPS. Except this one runs on memory instead of orbit, and it has been running in human skulls for a very long time. This is not something you're simply born knowing how to do well. A 2023 study published in PLOS One looked at orienteering athletes, people whose entire sport revolves around reading terrain and navigating without marked trails. Arguably one of the closest modern equivalents to how a hunter-gatherer once moved through the land. The experts showed stronger, more efficient hippocampal function than people with similar fitness levels who simply hadn't trained this specific skill. The difference wasn't raw talent. It was practice. Think about what that actually means. Somewhere in your skull is biological hardware built for exactly the situation your ancestors faced every single day. Walking out from camp, tracking prey, gathering food, then turning around and finding their way home again, sometimes hours later, sometimes with the light already fading. Every one of those trips left a trace, quietly training a map that never had to be drawn, because it was already being built in real time, inside their heads. But a map like this depends on something. It needs material to work with. Landmarks, slopes, bends in a river, something for the brain to grab onto and remember. So what happens when all of that disappears? When the ground stretches flat and white in every direction? When every hill looks like the last one? When there's nothing left to anchor a memory to it all? For generations, Inuit hunters crossed exactly this kind of terrain and still made it home, trip after trip, without ever getting lost. Not because the landscape secretly had landmarks after all, it didn't. They simply weren't reading the ground the way an outsider would try to. They were reading the wind. Across the Arctic, wind tends to blow from a consistent direction for long stretches of time. and that wind leaves a signature behind. It carves the surface of the snow into small ridges and grooves called sastrugi, shaped again and again by the same prevailing airflow. To someone who hasn't been taught what to look for, sastrugi is just texture, barely worth a glance. To a trained hunter, it's a compass carved directly into the ground, one that works even when clouds swallow the sky and there isn't a single star to steer by. Researchers Claudio Aporta and Eric Higgs spent time directly with Inuit hunters in the community of Igloolik, documenting exactly how this system works. What they found wasn't a single trick. It was a layered set of tools working together. Hunters read wind-carved snow. They tracked the position of the sun and stars when visible. They paid attention to the behavior of animals, since certain species move with remarkable consistency relative to coastlines and ice edges. They also relied on constructed stone markers called inuksut, standing landmarks built specifically to guide the way across otherwise featureless terrain. None of this came naturally. That's the part worth sitting with. Children in these communities weren't simply born knowing how to read a snowdrift. They spent years learning by walking alongside adults, listening to stories, watching, failing, and trying again, until the terrain that looked blank to a stranger became something they could read like a language. There was no single lesson where it all clicked. It was closer to how you slowly learn to recognize a familiar voice in a crowded room, built one repeated exposure at a time, until the pattern stopped being noise and started being information. Now picture a whiteout. Wind screaming, visibility dropping to almost nothing, snow blotting out the horizon completely. In that moment, a hunter can't see the sky, can't see the shape of the land ahead, but by kneeling down and running a hand across the snow, or simply looking at the ridge pattern directly beneath their feet, they can still tell which direction they're facing. The storm took away almost everything. It didn't take away the wind's signature. Here's the part that should genuinely surprise you. When GPS devices arrived in these communities, they didn't just supplement traditional navigation. In some cases, they made things more dangerous. Aporta and Higgs documented cases where younger hunters, relying on GPS instead of traditional knowledge, followed the device's route in low visibility straight toward areas experienced elders would have instinctively avoided. Stretches where sea ice was known to be thin or unstable near what's called the floe edge. A GPS device calculates the shortest distance between 2 points. It has no idea that the shortest line on a map might cross straight through the most dangerous ice in the region. Traditional routes, passed down and refined over generations, already knew to bend around these exact spots. The technology didn't have that memory built in. The people did. That's the real difference. GPS can tell you where you are. It has never once been able to tell you what a place remembers, what it has learned to fear, or which stretch of ground has quietly killed someone before. Out here on land, at least, there's still something to read. Wind carves the snow. Animals leave patterns. The horizon, however faint, still exists. But what happens when even the ground disappears completely? When there's no snow to carve, no coastline to follow, nothing beneath you but water in every direction, and the nearest shore is so far away it isn't even a smudge on the horizon? Now imagine that even the snow beneath your feet disappears. There is no mountain ahead, no river beside you, and no line of trees behind you. There is only water. The horizon looks almost identical in every direction, and the land you are trying to reach lies so far away that you cannot see it. On solid ground, a wrong turn may cost hours. Here, one mistake can carry you into the open ocean. This was the challenge faced by people moving from what is now Taiwan toward the Ryukyu Islands of southern Japan, roughly 30 to 35 years ago, even when sea levels were lower. The shortest crossing from Taiwan to Yonaguni was still about 105 kilometers. Worse, the route cut across the Kuroshio, one of the strongest ocean currents on Earth. Like the Gulf Stream in the Atlantic, it moves a vast body of warm water with enough force to push a small vessel far away from its intended destination. For a long time, it was tempting to imagine that ancient travelers reached these islands by accident. Perhaps a storm tore a simple raft away from shore. It sounds plausible until you examine the route. A slow raft caught in the Kuroshio could sweep its passengers northward or out into waters where thirst and exposure would become fatal. Accidental drifting is possible, but it does not adequately explain repeated settlement across this dangerous seascape. No wooden boat from this crossing has survived. Wood decays, especially in warm coastal environments, so archaeologists cannot uncover a Paleolithic canoe and inspect its design. The evidence is indirect. Humans reached the islands. Stone tools indicate woodworking ability, and the geography demanded capable watercraft. But what kind? To test the possibilities, Yusuke Kaifu and his colleagues did something unusually direct. They tried to make the journey using vessels that ancient people could plausibly have built. Earlier experiments tested a reed raft and then a bamboo raft. Both attempts failed to provide a convincing solution. The vessels were too slow or too difficult to control against the current. That failure mattered. It showed that floating was not enough. A craft crossing the Kuroshio needed speed, stability, and the ability to respond to deliberate steering. The team then turned to a dugout canoe, a long wooden boat shaped from a single tree trunk. Using reconstructed stone tools, they built a canoe about 5 meters long. In 2019, a crew of 4 men and 1 woman, set out from Taiwan. They carried no modern motor and could not rely on a conventional navigational instrument to direct the crossing. They paddled using the sun during the day, the stars at night, and the movement of the sea around them. The crossing was punishing. The crew traveled roughly 110 kilometers in about 45 hours. You are not making one heroic burst of effort. You are paddling hour after hour while the current moves beneath you. Darkness arrives. The shore disappears, and the island ahead remains invisible. Fatigue weakens every stroke, while stopping gives the current more time to carry you sideways. Yet the canoe reached Yonaguni. That success did not prove that this exact canoe design was used by the original Paleolithic travelers. No surviving boat allows us to make that claim, but it demonstrated something essential. A craft made with technologies available to ancient people could complete the crossing, while the simpler rafts tested earlier could not. The voyage was technically possible, but it required a controllable boat, a strong crew, sustained cooperation, and genuine navigational judgment. The experimental voyage answered one question and opened another. How could ancient paddlers choose a course when the Kuroshio was constantly dragging them away from a straight line? In 2025, Yu Lin Chung and colleagues combined the experimental results with computer simulations. Multiple ocean models examined present and reconstructed late Pleistocene conditions. The researchers tested where travelers should depart, which direction they should initially paddle, and how the current would reshape the route. The simulations produced a striking result. The best strategy was not to point directly at Yonaguni and paddle toward where the island ought to be. A successful crew needed to anticipate the sideways force of the Kuroshio. Departing from relatively sheltered water in northern Taiwan offered a more favorable beginning. From there, paddlers could first head east to east-southeast, then adjust toward the northeast, allowing their active steering and the current to combine into a path toward the island. The route that looks wrong at the beginning can bring you home at the end. A navigator compensating for current aims away from the destination because the environment will move the vessel. Ancient travelers needed no equations, but if this model reflects their method, they needed practical knowledge. How the sea pulls a boat, how long to hold a heading, and when the sun or stars call for an adjustment. This is why the crossing is more than a story about courage. Courage alone cannot tell you which direction to paddle for nearly 2 days. Strength alone cannot prevent a current from carrying you past an unseen island. Survival depended on shared timing, coordinated effort, and information accurate enough to guide a crew across water with no visible finish line. A canoe was not merely a hollowed tree. It was accumulated knowledge given a physical form. We should still be careful. The 2025 studies established that such a crossing was feasible and that high-level navigation would have improved the odds of success. They do not let us watch the thoughts of people who lived 37 years ago. We cannot know whether they understood the Kuroshio through earlier fishing trips, coastal journeys, stories from other travelers, or repeated attempts. The suggestion that they learned the current through experience is reasonable, but it remains a hypothesis rather than a confirmed fact. Even with that uncertainty, the conclusion is difficult to ignore. People reached islands separated from Taiwan by deep water and a powerful current. The tested reed and bamboo rafts failed. A steerable dugout canoe succeeded. Simulations showed how a favorable departure point and deliberate compensation for the current made the crossing understandable. What looked like luck now looks much more like skilled decision-making. But skill this complex cannot begin from nothing each time a canoe leaves shore. Someone must teach which trees make a workable hull. Someone must remember the safe bay. Someone must explain what the waves, sun, stars, and current are doing. And someone must preserve the lesson after the first navigators are gone. So how did knowledge capable of crossing an ocean avoid disappearing after a single generation? The answer was not to place the entire route inside one person's memory. It was to place it inside a culture. Among Aboriginal peoples of Australia, one clear example can be found in systems often described in English as songlines, or dreaming tracks. They are more complex than either songs or maps. A songline may connect stories, law, ancestry, sacred meaning, practical knowledge, and a sequence of real places. It is a way of organizing knowledge through the land. Imagine carrying a story whose events unfold in a fixed order. One verse corresponds to a hill, another recalls a river bend, the next identifies water or food. As you move, the landscape prompts the narrative. and the narrative tells you what should appear next. Remembering the sequence becomes a way of following the route. Each landmark works as a memory anchor. Coordinates are abstract. A hill associated with a vivid character, action, or ancestral event is harder to forget. Linked in order. Such anchors turn the landscape into an external memory system. The ground itself helps carry the information. Research by Ray Norris and Bill Yidam-Duma, Harney on Wardaman and other Aboriginal traditions shows how these systems could function as oral maps. Roots were embedded in stories, ceremonies, songs, and relationships between places. Knowledge passed from experienced custodians to younger people through teaching and travel. Some traditions connect roots on the ground with patterns in the sky. Stars provide direction but can also cue a sequence of terrestrial locations. The sky becomes both compass and memory aid, helping a traveler recall the order of places below. The Dawes Review of Australian Aboriginal Astronomy and Navigation emphasizes that this knowledge required no physical star chart resembling a modern map. Songlines show that information can remain structured when attached to place, repeated socially, and protected by responsibility. This created a form of error correction. A person might forget a verse or confuse a detail, but navigational knowledge was tested against reality. If a waterhole did not appear after the named ridge, the mistake became visible. Knowledgeable people could correct the account, while repeated journeys reinforced the working version. The community added another safeguard. Different people could hold overlapping parts of a route and confirm them through shared practice. Accuracy was supported by both landscape and group. The path corrected the story, and the community corrected the storyteller. Songlines did not exist only for practical travel. Access could depend on age, role, initiation, and cultural authority. They carry spiritual, legal, and social meanings that cannot be reduced to survival instructions. Navigation reveals one function, not their full significance. We must also avoid treating present-day Aboriginal traditions as unchanged fossils of Paleolithic thought. They belong to living cultures with their own histories. They cannot tell us exactly what a navigator in another part of the world believed 37 years ago. What they demonstrate is a human possibility. A society without writing can preserve detailed spatial knowledge through memory, story, repeated movement, and collective responsibility. That possibility changes the ancient ocean crossing. Paddlers facing the Kuroshio may appear alone, but success depended on knowledge accumulated before launch. Where to depart, how to make the hull, how the current behaves, and which signs reveal a change in direction. The crew carried lessons learned by absent generations. This may be the most important map ancient humans possessed. It lived in repeated journeys, remembered places, shared stories, and people trained to pass them forward. One person could die without taking the route with them. A child could inherit knowledge of a distant place before traveling there. Ancient wayfinding, then, was not only the achievement of exceptional navigators, it was the achievement of communities that learned how to remember together. But a living map survives only while people continue to learn it, practice it, and need it. What happens when a new tool makes that entire system seem unnecessary? For thousands of years, finding your way required you to pay attention. Then, within a few decades, a small screen began doing most of that work for you. GPS is extraordinarily useful. It can guide you through an unfamiliar city and help rescuers locate someone in danger. The problem is that when it works, you no longer need to build the same detailed relationship with the landscape. Claudio Aporta and Eric Higgs documented this change among Inuit hunters in Igloolik. Safe travel across Arctic sea ice involved more than knowing the shortest line between coordinates. Experienced travelers read winds, snow, tides, animals, ice conditions, and established routes. A trail mattered because generations had learned which dangers it avoided. GPS changed that relationship. A younger hunter could follow a direct digital bearing without learning every traditional route, but the device knew only location and direction. It did not know where sea ice had cracked, where a flow edge was unstable, or why experienced hunters followed a route that looked inefficient. In one case discussed by the researchers, hunters relying on GPS encountered danger when their route brought them toward hazardous ice conditions that traditional travel knowledge would have helped them avoid. The technology provided accurate coordinates, yet the journey was still unsafe. The screen knew where they were. It did not understand the place. Traditional wayfinding contains information that does not always look like navigation, where ice breaks, how weather changes a trail, and when the direct route should be rejected. GPS can draw a line. Cultural knowledge explains whether to follow it. This does not mean Inuit hunters should abandon modern equipment. GPS can save lives when used alongside local knowledge. Danger appears when a supporting tool replaces observation. Teaching. and judgment. If younger travelers stop learning the old signs, that knowledge may disappear unnoticed. Spatial skill follows a simple rule: use it or lose it. If a device always chooses your turns, tracks your distance, and announces your arrival, your internal map receives less practice. The capacity remains, but becomes less reliable because you rarely ask it to work. You may already recognize the feeling. Your phone loses its signal in an unfamiliar neighborhood, and a route you followed only minutes earlier suddenly feels impossible to reverse. You remember the blue line, but not the street names. You remember the voice saying turn right, but not the building on the corner. You traveled through the place without truly learning it. Ancient humans could not afford that kind of inattention. Missing one landmark could separate you from water, shelter, food, or the people waiting for you. Every journey trained the map in your brain, while every story and shared route added knowledge inherited from others. Today, being lost usually means arriving late. For your ancestors, it could mean never returning at all. Yet the difference between their mind and yours may not be a missing biological gift. It may simply be practice. And if that practice disappears, what remains of the map that once guided an entire species home? So how did ancient humans find their way home without maps? There was no single trick or mysterious sixth sense. Their brains constructed cognitive maps from experience. The hippocampus connected landmarks, distances, directions, and sequences into an internal picture of space. Path integration helped travelers estimate how far they had moved and how their direction had changed. But the map inside the brain was only the beginning. Ancient travelers learned to read a world modern people often pass without noticing. A ridge revealed a route. Wind carved direction into Arctic snow. The sun and stars provided bearings. Waves and currents showed how a canoe moved sideways. Animals, rivers, ice, and vegetation became navigational information. Nature provided signals, and survival depended on learning their meaning. Most importantly, no individual discovered every signal alone. Communities carried the knowledge. Parents guided children. Experienced travelers corrected younger ones. Stories joined places into memorable sequences. Songlines attached routes to landscape, culture, and responsibility. A lesson from one dangerous journey could protect someone generations later. Return now to the hunter from the beginning, standing far from camp while the sun sinks toward the horizon. At first, he appeared completely alone. He had no compass, no road, and no glowing marker telling him where to turn. Yet his mind was crowded with guidance. He carried landmarks learned during earlier journeys, warnings repeated by older travelers, remembered changes in wind, and routes tested long before he was born. I was walking alone, but he was not finding the way alone. That may be the deeper answer to this entire question. Humanity's greatest survival advantage was never simply stronger muscles, sharper eyesight, or one unusually gifted navigator. It was the ability to turn personal experience into collective knowledge. One person could notice a current, another could remember where ice became dangerous. A community could preserve those discoveries, correct errors, and hand the resulting map forward. GPS now performs part of that work with astonishing speed. It can tell you where you are more precisely than any ancient traveler could. But precision is not the same as awareness. When a screen selects every turn, you may reach a destination without learning the route, noticing the landscape, or building a map of your own. Your ancestors could cross frozen emptiness, return through unfamiliar wilderness, and even navigate toward islands hidden beyond the horizon. They did it not because they possessed magic, but because they paid attention, practiced constantly, and remembered together. So if your phone lost power right now, somewhere you had never been before, how much of that ancient map would still remain inside you?